Learning goals. Welcome to this learning session on understanding and creating pictograms. In this course, we shall address introduction to pictograms and keys, interpreting pictogram data, constructing and completing pictograms, understanding tallies, advanced pictogram applications. There will be a quiz at the end to test your knowledge.
Introduction to pictograms. A pictogram is a visual representation of data where pictures or symbols are used to denote quantities. This method is particularly effective for presenting data from tally charts or frequency tables in an easily digestible format. The primary purpose of a pictogram is to make data more accessible and engaging, especially for audiences who might find traditional graphs or tables less intuitive. They are widely used in educational settings and public information campaigns due to their simplicity and immediate visual impact. Historically, pictograms have roots in ancient civilizations, where early forms of writing often used pictorial symbols to represent objects or concepts. Modern pictograms continue this tradition, leveraging visual cues to convey information quickly and effectively across language barriers. The essential role of the key. Every pictogram must include a key, which is a crucial component that defines the value represented by each symbol. Without a key, the symbols in a pictogram would be ambiguous, making it impossible to accurately interpret the data. The key acts as a legend, translating the visual symbols into numerical quantities. For instance, if a pictogram uses a television symbol to represent viewers, the key might state that one television symbol represents two people. This clarity ensures consistent understanding. Different keys can be used for different pictograms, even if they depict similar types of data. For example, one pictogram might use a key where a symbol equals 5 units, while another uses a key where the same symbol equals 10 units. This flexibility allows for adaptation to various data scales, but it also underscores the absolute necessity of always checking the key first. Interpreting pictogram data. Interpreting a pictogram involves carefully reading the symbols in each row and applying the value specified in the key. For instance, if a television symbol represents 2 people, then 6 television symbols in a row would represent 12 people. Understanding partial symbols is equally important. If a full television symbol represents 2 people, then half a television symbol would represent 1 person. This allows for more precise data representation, even when quantities are not exact multiples of the full symbol's value. To calculate the total number of items or people in a survey, you simply add together the totals from each individual row. For example, if the rows represent 12, 9, 2, and 7 people respectively, the total survey participants would be 12 plus 9 plus 2 plus 7, equaling 30 people. This aggregation provides a complete overview of the collected data. Constructing pictograms, worked example. Constructing a pictogram requires careful attention to the key and the data values. Consider an example where a pictogram shows the number of films Adam watched, with a key where a block of 4 squares represents 4 films, a block of 2 squares represents 2 films, and a single square represents 1 film. Using this key, we can interpret existing data. If June shows 2 blocks of 4 squares, Adam watched 8 films. Similarly, if August shows 1 block of 4 squares and 1 single square, Adam watched 5 films. This demonstrates how different combinations of symbols can represent various quantities. It's important to note that the choice of symbols and their values in the key should be logical and easy to divide, often using factors like 2, 4, or 5. This makes it simpler to represent partial values accurately and consistently across the pictogram. Completing a pictogram involves accurately representing data using symbols based on a defined key. This ensures clear and professional data visualization. To complete a pictogram for a new data point, you must first determine how many symbols, including partial ones, are needed to represent the given value based on the established key. The process involves breaking down the total into multiples of the key's symbol values. For example, if Adam watched 10 films in September and the key defines a block of 4 squares as 4 films, a block of 2 squares as 2 films, and a single square as 1 film, you need to combine these. Representing 10 films would require 2 blocks of 4 squares, 4 plus 4 equals 8 films, and 1 block of 2 squares, 2 films. This combination perfectly sums to 10 films. Accuracy and neatness are paramount when drawing the symbols. Each symbol should be clearly distinguishable and consistently sized to maintain the pictogram's readability. This ensures that the completed pictogram remains an effective and professional data visualization tool. Understanding tallies. Tallies are a simple and effective method for counting and recording data, often used as an intermediate step before creating pictograms or other charts. A single vertical line represents 1 unit, making it easy to track occurrences in real time. To make counting large numbers more efficient, tallies are typically grouped into 5s. 4 vertical lines are drawn, and the 5th unit is represented by a diagonal line crossing the previous 4. This gate of 5 allows for quick visual counting, similar to how we count fingers on a hand. For example, to represent the number 12 using tallies, you would draw 2 groups of 5, HT, and then 2 additional single lines, 2. This method is particularly useful in situations where data is being collected continuously, such as counting votes or observations in an experiment, as it minimizes errors and speeds up the counting process. Advanced pictogram application. In more advanced applications, you might encounter pictograms where the key is missing, and you need to deduce its value from given data points. For instance, if a pictogram uses house symbols to represent average house prices, and you know the price for one county and the number of symbols it has, you can calculate the value of a single house symbol. If Herefordshire has an average house price of £225,000 and is represented by 9 house symbols, then each house symbol represents £225,000 per 9 equals £25,000. Once the key is established, it can be applied to all other entries in the pictogram. After determining the key, you can then complete the pictogram for other counties or work out unknown average house prices. For example, if Essex is represented by 8 house symbols, its average house price would be £25,000 equals £200,000. This demonstrates the power of proportional reasoning in interpreting and completing complex pictograms.
Summary. Well done, you have completed the course, Understanding and Creating Pictograms. You should now be familiar with Introduction to Pictograms and Keys, Interpreting Pictogram Data, Constructing and Completing Pictograms, Understanding Tallies, Advanced Pictogram Applications. Should you need to revisit any of the topics in this course, please use the menu at the bottom of the screen.